NASA's groundbreaking X-59 Supersonic Aircraft has just reached a major milestone that could reshape the future of air travel. In a significant step forward, the experimental aircraft completed its first maximum afterburner engine run this December at Lockheed Martin's Skunk Works facility in Palmdale, California. This achievement brings us closer to a future where civilian supersonic flights could become a reality, flights that go faster than the speed of sound without disrupting communities below with the infamous sonic booms. The X-59's development is part of NASA's ambitious Quiet Supersonic Technology (QueSST) program. This program's primary goal is to demonstrate that it's possible to achieve supersonic flight over land without the harmful noise caused by traditional sonic booms. Currently, Federal Aviation Administration (FAA) regulations prohibit supersonic flights over populated areas due to the loud shockwaves created when an aircraft exceeds the speed of sound. However, the X-59 is designed with advanced technologies to address this issue, offering the hope of quieter, faster travel without disturbing the environment below. This December's Afterburner test marked a critical step in the aircraft's progression. The X-59 is powered by the F414 GE100 engine, which NASA engineers have been fine-tuning for its supersonic capabilities. With a thrust of 22,000 pounds and a top speed of Mach 1.4, roughly 925 miles per hour or 1,489 kilometers per hour, this engine will propel the X-59 to altitudes of up to 55,000 feet. This milestone test is essential for verifying that the aircraft can achieve these speeds and altitudes while maintaining the necessary quiet operation for overland flight. The design of the X-59 is radically different from traditional supersonic aircraft, and this design is central to the aircraft's quiet flight goals. The most noticeable feature is the long, pointed nose and delta wing shape, which are specifically engineered to reduce the shockwaves responsible for sonic booms. These innovations help smooth out the airflow around the aircraft, minimizing disruptive noise. In a further departure from conventional designs, the X-59 is windowless. Instead, it uses external cameras and interior screens to provide the pilot with real-time visual feedback, reducing drag and enhancing aerodynamics for improved performance. One of NASA's primary objectives with the X-59 is to reduce the sonic boom to just 60 decibels, about the same volume as a car door closing. In comparison, a traditional supersonic aircraft like the F-16 fighter jet generates a noise level of around 78 dB, while the famous Concorde produced an ear-splitting 100 dB during its supersonic flights. The quieter noise generated by the X-59 could revolutionize the aviation industry, making overland supersonic flights not only possible but practical for the first time. This quieter sonic boom could also eliminate the main obstacle that led to the Concorde's retirement: the noise complaints from people living in the flight paths. While the X-59 is not intended to become a commercial airliner or a production aircraft, its purpose is to gather vital data that will inform the future of supersonic civilian air travel. This aircraft is a testbed for the technologies and regulatory challenges that must be overcome for commercial supersonic flight to be viable. By collecting flight data, NASA will help shape the future of supersonic airliners, pushing the boundaries of aviation technology. The X-59 features a single pilot cockpit, and its windowless design is just one of many innovations aimed at gathering critical data for future supersonic aircraft. The aircraft is currently in the midst of extensive testing, with flight testing expected to begin in early 2025. The results of these tests will provide insights into the feasibility of supersonic commercial flights, offering the potential for cutting travel times across continents and drastically improving the efficiency of long-haul air travel. NASA's X-59 is more than just a technological marvel. It represents a bold step toward a future where supersonic air travel is not only faster but also quieter and more environmentally considerate. As testing continues over the coming months, the X-59 could pave the way for an entirely new chapter in aviation, where we can enjoy the speed of sound without the disruption.